Hi everyone, my name is Makumba Gerard of EduMath. Now in this video, we are still going to be looking at one of the measures of dispersion, and that is the quartiles. And if you're new here at EduMath, consider subscribing and hitting that notification bell. For now, let's jump into it. So we're going to start by having a quartile being defined here. The quartile is a value which divides the given data into 4 equal portions. So we denote quartiles with Q subscript 1, that's the lower quartile. Then the second quartile, which is the same as the median. We are going to see that. Then in Q3, we call it the upper quartile. I'm going to take this line here. I'm going to assume that this line here is the full span of our data. We are saying that a quartile is a value which divides the distribution into 4 equal parts. So these are 2 equal parts dividing here equally. Also, these are 4 equal parts. So this is the one which is Q1, the lower quartile. This is Q2, and this is Q3, and this is the starting point of our data. This is the end point of our data. Okay. Now this data here has been arranged in order. The order can be either ascending or descending, and this is the reason as to why we are going to modify the formula for median while finding the quartiles for grouped data. Even for the case of ungrouped data, we shall just be modifying a way of finding the median. So you're going to see this. When you look at this data here, these classes here are arranged in ascending order. You can see that we arranged this from the small class to the big class. Okay, so this is a question that we are going to do. So let's see how we can be able to modify the median. We're going to start with a review. So here we go. We say median is given by this formula here. L1, the lower class boundary of the median class. Fm is the frequency of the median class. CFB, this here is the cumulative frequency before. And then this C is the class width of the median class. This smaller n is the summation of F. This is the formula which we use while finding the median. Now, we're just going to be modifying this formula here to get Q1 and Q3. We can observe that Q2 is in the middle. So from here up to here, so if the whole of this line here is a distribution having n members, then from this point to this point, this is a half n, which comes at this point here. Now, if this line here is divided into 4 equal parts, that means this is a quarter of the whole distribution. This is also a quarter of the whole distribution, a quarter of the whole distribution, a quarter of the whole distribution, right? So Q1 here is the lower quartile, which is here. Now, for the case of median, which is from here to here, we are seeing that in this position we have a half n. Now, when it comes to lower quartile, which is at this point here, we are going to replace this value here with a quarter. And then the rest of the things remain the same. LQ1, this is the lower class boundary of the lower quartile class. Then FQ1, this is the frequency of the lower quartile class. CFB is the cumulative frequency before. We're going to see that. Then capital C is the class width of the lower quartile class. And smaller n is the same as this, summation F. Okay? So the same thing is going to happen when it comes to getting the upper quartile. So the upper quartile is this Q3, which is now we are stretching from this side to here. Now these are 3 quarters from here. These are 3 quarters of the whole distribution, right? And this 3 quarters is what has come here. And then the process of determining the upper quartile is just the same, right? Now we shall go ahead to find the interquartile range, which is got by getting the upper quartile minus the lower quartile. Then we shall also go ahead and find the semi-interquartile range given by this formula. Semi-interquartile range is half of the interquartile range, right? So with this background, we can start on with a guiding question. The table below shows the weights of a sample of 30 patients in a particular health center. This is the table. The industry use that table to find the median, the lower quartile, the upper quartile, interquartile range, and finally the semi-interquartile range. When it comes to computing the median, we need only the cumulative frequency and then the class boundaries. So our task here is that we are going to go ahead and have the class boundaries and also the cumulative frequency columns on. Alright, the new table has to include the class boundaries and the cumulative frequency. So within this table, we are going to have the weight, have the frequency, which stands in for the number of patients. So we fill in first the weights and the frequency. Now, because we need these parameters, all these parameters depend on the cumulative frequency and the class boundaries. So in this table here, we're going to include cumulative frequency, and then we shall have the class boundaries. Now, why do we bring in class boundaries? They come in to make our data continuous. I'm going to link a video about class boundaries in the cards. So first, let's get the cumulative frequency. The 3 is transferred here, that's the initial value. 3 plus 5, we get here 8. 8 plus 10, 18 here. 18 plus 7, get here 25. 25 plus 5, we get here 30. Meaning that summation F is equal to 30 here. Now we are remaining with getting the class boundaries. Know that the tolerance error, this is going to be equal to half times 10 to the negative n. N is the number of decimal places. Now when you look at our data here, it is to 0 decimal places. So n is 0, and therefore our tolerance is going to be 0.5. So we are going to take our 0.5 from the lower class limit and then add 0.5 on the upper class limit. So this is going to be 59.5 to 64.5. Then this will be 64.5 to 69.5, and so on for the rest of the other classes. We are now going to calculate the median. Median, which is in part A here, is given by the formula this here. So first we are going to find the median position, which of course starts from here. So we're going to have 30, which is n, okay, all over 2 value. Okay, so median is the 15th value. So when you look at our table here, the 15th value lies here. Of course, we check these positions under cumulative frequency, because cumulative frequency shows positions. Alright, so median is a value that lies here, meaning that the lower class boundary of the median class is 69.5. Frequency of the median class is 10, then cumulative frequency before is 8. Let's substitute in here. Therefore, median is going to be 69.5 plus, that's the lower class boundary, n over 2 gives us 15, minus cumulative frequency before was 8, divided by frequency of the median class, we got it as 10, we saw that, then times the class width. Our class width here is 5. We just get the upper class boundary minus the lower class boundary. So 74.5 minus 69.5, it gives us 5 as the class width. So that's the one which you're going to substitute here in the position of C. By 5, once by 5 get 2, then 15 minus 8 we get 7. 7 divided by 2 we get 3.5. So this is 69.5 plus 3.5. So the median, when you add that, it becomes 73. Now the steps which we have taken while computing the median are the various steps which you are going to take while computing the lower quartile, the upper quartile, and then we shall go ahead to find the interquartile range and finally the semi-interquartile range. So let's get started with finding the lower quartile, Q1. This is given by the formula. You can just use L1, knowing that this will be the lower class boundary of the lower quartile class, plus this is a quarter and minus cumulative frequency before all over frequency of the lower quartile class times C. That C is the class width of the lower quartile class. So it starts from here. We start with the Q1 position. This is going to be 30 all over 4. And this gives us 7.5 value. Okay, now this value lies in 8 here, right? Yes, it's above 3, so it has to lie here, meaning that we can right away get Q1 from here. The lower class boundary of the lower quartile class is 64.5 plus this is 7.5 minus cumulative frequency before is 3 divided by frequency of the lower quartile class is 5, then times the class width is also 5 by 5 once, by 5 once there, and this is 4.5 here. So when you add this, Q1 is going to be equal to 69 as our lower quartile value. Next we proceed to getting Q3 here, which is the upper quartile. Q3 is equal to L3 plus 3 all over 4 and minus cumulative frequency before all over frequency of the upper quartile class times C. Now we start with the Q3 position, which is equal to 3 all over 4 and value. We start from this point here. So this is going to be 3 times 30 divided by 4. And that position is 22.5 value. Okay, so the next thing here is we go back to our table and identify where 22.5 lies. So 22.5 is a value that lies in there. Alright, so when we look at our table here, the cumulative frequency before is 18, the frequency of the upper quartile class is 7, and then the lower boundary of the upper quartile class is 74.5. So that's what you're going to substitute right over here. We have therefore Q3 is equal to 74.5 plus this is now 22.5 minus cumulative frequency before we saw that it is 18 divided by frequency of the upper quartile class 7, and still there the class width is 5. So when you compute this very well, we are going to end up with 77.4143, and this is to 4 decimal places. Okay, so we've seen how to get the lower quartile, we've seen how to get the upper quartile. Of course, we started with a review, getting the median. The next thing which the question demands us here to do is finding the interquartile range. Interquartile range is very simple to obtain. Interquartile range is equal to Q3, the upper quartile, minus the lower quartile here. So we got our upper quartile as, this is Q3, as 77.4143, 77.4143 minus Q1, which is the lower quartile, is 69. So there, when we subtract, we shall be getting 8.4143. That's the interquartile range. Then we have semi-interquartile range. This is equal to half of the interquartile range, Q3 minus Q1. So this is going to be a half into bracket. Q3 minus Q1 is this value, 8.4143. So semi-interquartile range is a value which is 4.3571. And this is also to 4 decimal places. cases. So as far as this question here is concerned, we are now done with solving all these parts. Now is the time for you, my dear viewer, to try out one. The table below shows a survey of the ages of elders in a particular parish. This is the table. Use the table above to find the median, lower quartile, upper quartile, interquartile range, and then same interquartile range. So my dear viewer, I'm so glad to have you being part of EduMath community. You can pause the video and have this question written down. So from us EduMath, we wish you the best and see you in the next video.